Now, what are things you should remember while learning this chapter of electricity? We have this chapter has been vastly shortened after COVID. However, you being bad luck children, many things have been reintroduced this year, which are not from the perspective of examination, but from the perspective of knowledge. You should know that. So how I will cover this chapter? First, I will cover the exam part of the syllabus, okay? And then additional part, this is my favorite topic. So here I will speak much more than required. So those we will definitely cover. So don't worry about it. This chapter is highly numerical intensive. Every class that I do, I will always, like a frog, slip back and revise the formulas that we had studied till starting that class. Maybe today we might not encounter any formula at all. Okay? Are we ready to study electricity? And there is one more thing called, in grade 12, we will be actually having a book which is all electricity only. Here it is a very small portion, but your concepts need to be clear. And if you mug up definitions, you will not understand anything. Right. So let's go up at a level now. First, generic discussion. We have got matter, and matter can be at last brought into what? Atoms. And when you bring matter into atoms and you enter the subatomic level, then you see three types of particles: the electron, the proton, and the neutron. While electron is associated with a negative charge, proton is associated with a positive charge, and the neutron is electrically neutral. Is this understood or not? It is electrically neutral. Understood? Now, like matter has got a fundamental property associated with it, is mass. Anything, how the concept of charge comes actually. Matter is something that has mass, occupies space, and can be felt, right? So a lot of experiments and other things were done up. So when you actually take out, say, suppose you pick up one electron and you pick another one electron, then going by gravitation that you studied, an electron and electron will also show what is known as an attractive force between these two. That attractive force, there is a force of attraction between these two. Mind you, I'm saying electron, force of attraction between these two, which is the gravitational force. This gravitational force in grade 9 we have studied, it is Gm1 m2 divided by r square. For us, more interesting is that the gravitational force is dependent upon the property which is known as the mass. And such sort of a law is called the inverse square law. When you come to grade 12, you will understand that, because you know this is a negatively charged particle, this is a negatively charged particle. So there should be some repulsion between them. Obviously, there is a repulsion also. And that repulsive force is an electric force. And this electric force is given by some constant K multiplied with the value of the two charges separated by, this is not in your scope, this is class 12. This electric force is given by some constant. Here it was G, here it is K. Here it is M1, M2, here it becomes Q1, Q2, value of the charges. This is called Coulomb's law, divided by the square of the distance, which also follows the inverse square law. Is this understood? This force is attributed because of another property of charge. Now we say, while an electron attracts another electron due to gravitational force, why is an electron repelling another electron? So there is another one force, which is known as the electrostatic force. And this is the most important force of the universe. That you are able to put your hand on the floor and get up is also an electrostatic force between your palm and the floor, which you will study later. It is one of the strongest force. We have studied about gravitational force. This is a force which we do not even take into consideration while doing any engineering design. We do not consider gravitational force while making a bridge or while designing a car. We'll get to know the example and why we don't. But this is very important. An electron repels an electron. Why? Then maybe there's some one force, and we say that is the electric force. Then what is this electric force attributed to? This electric force is attributed to another property of matter. Matter, apart from mass, has got another one property, which is known as charge. Have you understood? It is known as charge. Then some more tests were done. They measured the value of this force of repulsion. They brought a proton out here, and again the force was measured. The force was found to be exactly equal in magnitude, but opposite in nature. सुनो story को सुनो आराम से. Two electrons, they found a repulsive force. Okay, let's bring two protons, again repulsive force. Magnitude of the force is same. Are you understanding? Magnitude for electron-electron repulsion, magnitude for proton-proton repulsion is same. Just see the beauty, children. Electron and another electron, okay, two electrons. Now you have a repulsive force between them. There's a repulsion force. Similarly, there is a proton, which is a positively charged. There is a proton. These also show a repulsive force. Magnitude of the force is same. But you have studied in grade 9. This is a far more heavier particle than this. Rutherford's experiment. The entire mass of the nucleus is attributed to the protons. So protons are much more heavy. So if you see proton-proton attractive force in gravitation, it is much more than electron-electron attractive force. Do you understand? Because proton's mass is more. Electron's mass is very less. But the repulsive force electric is exactly same. This makes us understand electric force has nothing to do with mass. Electric force has something to do with charge. Then they did one more experiment where an electron was brought in the vicinity of a proton. Now the force is found to be attractive. Magnitude is again same. Magnitude is again same. Now if you see these three, what all conclusions you can draw? This force is due to charge, this force is due to charge, this force is due to... All three forces magnitude wise are equal. That means the charge of an electron, must be exactly same as the charge of a proton when I consider only the value of the charge. However, when I do this, then I say the polarity of electron charge must be exactly opposite. You know, in English, opposite is shown by the cross sign. Must be opposite to the polarity of proton charge. How many of you understood this discussion? What I tried to say. Gravitational force we know. Usko bhul jaiye. If you compare them on gravitational force, then the forces are different for electron, proton, because the masses are different. But when you see electron repulsion, proton repulsion, the value is exactly same. Means who is contributing? The charge values are exactly same in terms of their magnitude. But when I bring proton and electron, I actually find that the same force exists now, but the nature is attractive. That means either somebody's polarity does not match another's polarity. Have you understood? Right? So from these, the discussion comes up. Charge is attributed to two types of polarity. One is a positive charge and one is a negative charge. This is our assumption. This is our assumption. And I used to say that glass rubbed with silk, GSP, gives you positive. That is how the protocol was made. And one positive, another object you bring, if it is attracted to this, this is also positive. If it is, sorry, this is also negative. If it is repelled by this, then this is also positive. That's how charge was classified. So charge is a fundamental property of matter. Matter may be electrically neutral, which means the number of positive charge a matter has is equal to the number of negative charges. And for matter to exist, this charge must balance. That is the reason you don't see oxygen atom, because oxygen atom is O2 minus. वो exist नहीं करेगा. But O2 exists. In O2, the electrical charge is neutral. Whatever you are able to see in front right now, everything is electrically neutral. Yes, you might get charged momentarily. I might charge a body. How do you charge a body? I might add some additional charge, or I might withdraw some charge from a body, or I might make the body's charges separate, create polarity. How do you create polarity? Suppose you have a ball out here which is neutral, and you bring only a positive rod out here. Positive rod. This rod is all positive. Then this side will have what? All negatives, because all the positives will be repelled and all positive. So you have polarized this body. Momentarily, this body has become polarized. Understood? So charge is an integral property of matter, and the charge can be of two types. In grade 10, the first thing we try to understand is the concept of this thing called charge. Charge is denoted by the small letter q, okay? And it will have an SI unit, and this SI unit is coulomb, C-O-U-L-O-M-B, coulomb, denoted by capital C. Clear? अब जो भी कुछ है थोड़ा सा फेरी टेल जैसा है. This charge q can be at rest, or this charge q can be moving. Okay. Now you all have studied this chapter, but you'll study it with a different perspective now. Can be at rest. If the charge is at rest, then the charge is static. All the study you do falls under the branch of electricity called electrostatics. In grade 12, G12, the first two chapters is all about electrostatics. Have you understood? Fine. If the charge is moving, the charge can move in two ways. The charge can move with uniform speed or velocity, or the charge can be accelerated. If the charge is moving with uniform speed, what gets created is known as current. Current, right? In grade 12, you will study 1, 2, 3, 4. 4 chapters will be related to current. And if the charge is accelerated, it creates something called waves. Our mobile phone has got a magnetic accelerator. The microwave oven, the heart of the microwave oven is a magnetron. It creates those magnetic, accelerates charge. So what is created? Electromagnetic waves, EM waves. This is creating EM waves. Once you ring me, the microwave tower generates a EM wave, and that microwave tower's EM wave is caught by my mobile, and then the acceleration circuit will create. That's why these are not so good for your ears and head. So waves, on this in grade 12, I will have one more chapter. Okay. You will never hear the word current when you are studying electrostatics. Because why? Charge move ही नहीं कर रहा है. This is swimming pool, stagnant water. This is river. This is sea. Waves will come out, accelerated. Are you understanding? We say everything when the charge is at rest is called electrostatics. All the things that you call, that when you see the thunderstorm or the lightning, that's a huge discharge. That is known as, that is not current. That is static electricity. When you go and you wear something which are having a lot of sequin dresses, have you felt it? Chat, 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 your body hair starts to get moved. Or sometimes if you're beside a curtain which is too much rayon and all, you touch the curtain. I have this property. Means in my body, charge develop happens very quick. If I sit in front of a large screen TV for some time, after that, if you come and serve me anything, be ready for one patch, one discharge. And have you felt that or not? That discharge and all happens due to static electricity. So is the concept of charge understood? Charge can be transferred. Charge cannot be destroyed. You can't destroy a charge, right? And when we transfer charge, charges are always transferred in discrete quantity. 1 coulomb, 2 coulomb, 3 coulomb. Can you give me half coulomb? Not possible. Can you take away half coulomb? Not possible. Take 1. So charge always goes in the plus minus n, where n is a natural number. Why minus? Negative charges. Is this much clear? What do we mean by here? So we're talking about electricity, where we first understood the charges are of two types. In our grade 10, we will be studying more on current, where the charge will be moving. Bore to nahi ho rahe ho? Because I see you all absolutely blank in your face. Okay. Chapter has still not started. Our next discussion is something about conductors versus insulators. Conductors versus insulators. Conductor. End of the day, whether you are a conductor or whatever, you will be taking birth from the 114 members which are known as elements. Elements only have to give rise to conductor. The first property of the conductor is that it is something which is solid. It is solid. If you are a solid, you can be a metal or a non-metal also. So if you are a solid, you can be either a metal or you can be a non-metal. All metals are good conductor of electricity. That's the first property of metals. Metals are malleable, metals are ductile, metals are good conductor of heat, and metals are good conductor of electricity. So all metals are conductors. In the case of non-metal, we have only one, which is carbon, but it has to come in a typical form, God in one form. And that form of carbon is known as graphite. We will see everything. First, let's get our basic knowledge. That is a conductor. Rest, nothing is a conductor. Is this clear? Sir, yesterday with my wet hands, I touched the bathroom switch and I received one jor ka jhatka. So that means it is not that conductors are only solid. A conductor can be a liquid also, but there is a difference. A liquid may conduct or a liquid may not conduct. If a liquid conducts, it is not called conductor. It is called electrolyte. And if it doesn't conduct, it is called non-electrolyte. Understood? Fine. There is a big difference. The difference is when conductors conduct electricity, there is no chemical reaction. However, when liquids conduct electricity, chemical reaction takes place. That's why this branch is studied under chemistry called electrochemistry. Electricity has three effects: heating, number two, magnetic, and number three is chemical. Remember your grade 8 chapter, chemical effects of electric current? We studied it under chemistry. These two are studied in physics: heating effect of current, magnetic effect of current. इलेक्ट्रिसिटी से हीट पैदा करना, इलेक्ट्रिसिटी से मैग्नेटाइजेशन करना, these are studied in physics. This is not studied in physics. This is studied in chemistry. Because here the entire chemistry changes. My flat is 12 years old. The wiring is done by copper wires. They are still copper today. But if they would have done wiring with sulfuric acid pipes, still electricity would have come. All those sulfuric acid would have changed. That's what happens in our batteries, inverter batteries and all. We keep on filling water, acidified water, because chemical reaction is continuously taking place. Is this understood? Conductors are solid and conductors are metals, barring an exception. Now question comes, sir, what is so special in metals? What is so special in metals? Very good. So let us go to metals. In metals, I will have a metal atom. The metal atom will have a nucleus, and around the nucleus there will be electrons who will be doing, here we go around the mulberry bush, and they will be turning around the nucleus. Do you agree or not? Such electrons are of two types. There are some electrons which are like very good electrons. No, I need to ask my mama, I just can't come for your birthday party. Mama se kya khali mama se puchte rehta hai? These electrons can be of two types. Mama electrons, which are known as bonded electrons. They are bound to the nucleus. What is your name? You see some kids in lift, they will look at you. What's your name? Hide behind the mother. Those are those. We have these kids. Those are known as bonded electrons. And there are some kids, तू घर में आएगा आज? अभी मैं खेल रहा हूं. Free electrons. Free electrons. Understood? These free electrons are like the chapri electrons of the atom. Chapri, you know? This is the chapri electron. These free electrons, now there can be atom 1, there is a atom 2, there is a atom 3. So atom 1 has got some mama electrons, they've got free electrons. अब ये free electron क्या करेगा? If you see one chapri boy in your apartment, this chapri boy will mix with another chapri boy of the same apartment, and all these chapris will be going together wherever possible. Do you agree or not? That's the chapri class. So all these free electrons are called When all these go up, this is called as a sea of electrons. Sea of electrons. Very good. This is the Chapri sea. Do they come to their homes? No. Sometimes at 10:30, their mamas keep their khana dhakke rakh do, aake kha lega. So we give them another name. They are called delocalized. Delocalized electrons. They are not local to any atom. Okay, let's keep the Chapri example in one way. All our towers in our apartment have got a wheelchair. Which is right there at our lobby. Can you take the wheelchair when you need it? Obviously, you have to sign it. Can you keep the wheelchair at your home? No. Did you pay for that wheelchair? Yes. You also paid. Kharida kahan se wo wheelchair? We all paid for it. Is it your personal resource? No. It's a delocalized resource. You don't own it. So these free electrons are known as the sea of electrons, also known as cloud of electrons, and are delocalized electrons. They are not associated with any atoms. Any substance, means substance, which has got this Chapri class of electrons will be a conductor. This Chapri class of electrons can be there by birth of the atom, due to some temperature changes in the atom. Semiconductors. What are semiconductors? Thali ka bangan. I am a little bit conductor. I am a little bit insulator. But if you change the temperature, I become superbly conductor. Means if you're a born Chapri, or if you get converted into a Chapri, you will conduct. And what is this conduction due to? Free electrons. So what have we understood? A conductor is a solid which conducts electricity by virtue of presence of free electrons. What are free electrons? Electrons which are not associated with an atom, which are a part of the sea of electrons, which are called delocalized electrons, are called conductors. A society or a housing society may have less number of Chapris, high number of Chapris. If you have high number of Chapris, you are a very good conductor society. If you have less number of Chapris, you are a poor conductor society, but you still conduct. But if there is a society where there is no Chapri at all, then you are a insulator. An insulator is not a bad conductor. A bad conductor is somebody who still conducts, but very, very less as compared to a good conductor. An insulator is someone which does not have any free electrons. Glass, it will never conduct. Have you understood? So let us look at the screwdriver. A screwdriver has got a green handle, which is the insulator. It has got the metallic bar. So if you are working on live, when you touch the metallic portion, you will get jingalala. So the metallic bar will have a yellow rubber sleeve, you will see. That is also insulator. And then the tip is the conductor. Kitna samajh mein aaya? Now question arises. Sir, what is the special story of this fellow? He is not from the Chapri class, but he behaves like a Chapri. So let us understand the case of graphite. Little bit high-end chemistry. Okay. To understand graphite, you have to understand the valency of carbon. Carbon has got, this is something which I'll draw in organic chemistry a lot. Carbon has got a valency of 4. If you look at the atomic number of carbon, carbon's atomic number is how much? 6. So its electronic configuration is 2, 4. It needs 4 more electrons, or it has to give away 4 more electrons, right? So it has got 4 open ports. Graphite structure, we have got something called graphite, we have got something called diamond. Both are carbon. Diamond does not conduct electricity at all. Conducts heat. That is a lattice structure issue. But graphite conducts electricity. दोनों के price में high difference. One is pencil lead available at 2 rupees. One is in crores. But if you burn both will give you carbon dioxide. I burned some diamonds and I inhaled the carbon dioxide. Both will give you carbon dioxide. ठीक है ना? So what is speciality? Children, if we look at the structure of graphite, before looking at the structure of graphite, let us understand something called electron sharing. When electron sharing happens, then what happens? Electrons move in what? Orbits. So I am one electron, I have an orbit. In higher classes, you will call this as an orbital, or in English, they say orbital. ये ऑर्बिट का कॉन्सेप्ट चला जाता है. What you have learned in grade 9 ना, there are some orbits in which electron moves. In grade 11 you'll study all these are bakwas. There is nothing called an orbit, there is something called an orbital. What is an orbital? A region around an atom where the probability of finding the electron is maximum. Very interesting definition. Orbital is something like the burial ground. A region in the vicinity where the probability of finding the ghost is maximum. What is that? Burial ground. Will you go at night to a burial ground? No, no. Why don't you go? Because the chances of finding a ghost is maximum. So if the ghost is an electron, the burial ground is the orbital. And there are different shapes of orbital. We have got spherical, dumbbell shaped, all this you'll learn in grade 9. So when sharing happens, I am an electron, I have my orbital, you are an electron, we are going to share. Your orbital and my orbital will overlap. And this overlap can happen in two ways. Head on. Head on. My orbit overlaps your orbit head on. And it can be sideways. Sideways means ऐसे. We have overlapped in this manner. If you do overlap head on, then the bond form is known as, abhi tum hasoge, it is called a sigma bond. Head on is called a sigma bond. It's a head on bond. And if you actually do sideways, it is known as a pi bond. Grade 11 stuff. Absorb, kuch nahi hota hai. So electron sharing may happen. Whenever an electron shares with an electron, a bond is formed. The bond can be a sigma or a pi bond. Sigma bond is very strong bond, head on overlap. Pi bond is a weak bond. Paristhiti and circumstances, I am sitting with you. Given a choice, I would never like to sit with you. I am sitting with you by compulsion, not by choice. That is a pi bond. Now let's look at the structure of graphite. This again we will study in metals and non-metals. Graphite is hexagonal in structure. Hexagonal means the structure of graphite is something like this. This is a hexagon. Agreed? Now let's see. Let me copy this. So we will have this. Okay. This is actually the structure of graphite. This is graphite structure. This is a carbon atom. Every carbon atom is linked with 3 other carbon atoms. These are all carbon atoms. Carbon. If you understood. You concentrate here. This carbon atom is linked with 1, 2, 3. Agreed? That means 1 satisfied, 2 satisfied, 3 satisfied. What happened to the 4th? That satisfaction also has to take place. So that satisfaction happens in this manner. Have you heard graphite is very soft? Why? Graphite forms very good layers. That's why you're able to sharpen a pencil very properly. And that's why it helps in lubrication also. One layer slides over the other layer. So children, I have got another layer which is just below this layer, Try to absorb this drawing. One layer over another layer. When this one layer over another layer happens, some magic starts forming, which is that these carbons develop something like a weak pi bond within them. ये तुम्हारा book नहीं बताएगा, तुम्हारा school भी नहीं बताएगा, समझो. These were all sigma bonds, head-on overlap. But this one is a pi bond. Acha. Have you seen movies where they show children kept in dormitories, in hostels? They all sleep in bunk beds. So you have a bunk bed row here and you have a bunk bed row here. This child and this child is a head-on overlap, whereas the children below them are pi overlap, sidewise. These pi bonds, the blue ones that I have drawn, these are electrons which are participating in bonds. These are the Chapri electrons. So this bonding is not permanent. It is like some sort of a butter which is there between the two layers. A cloud of electrons, not necessarily localized. That's the reason one can slide over the other. If you would have made hard linkages, one cannot slide on the other. Are you getting the crux of it? They are delocalized. but they are all grouped. All the chapris are together. So it's like a layer of mayo you have put between the two hexagonal layers. Does the mayo bond the two breads? Yes, it does. Does it bond it strongly? No. बच्चा ऐसे पकड़ गिर गया सब बर्गर से, वैसे यहाँ से भी गिर सकता है. So whenever this mayonnaise formation happens, the material will conduct. That's the reason graphite conducts. Though it is carbon. Now you can ask, sir, what is diamond? Diamond is tetrahedral. Carbon, 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 and again backside there is also one linkage. How is this? A triangle with something taken on top. ये carbon नीचे से भी linked है. All the carbons are linked. Here you cannot expect electrical conduction. Here electrical conduction happens. So today our class stops with, I hope you understood what is charge, what is polarity of charge. Then we spoke about, we have still not spoken about electron charge and proton charge. We'll speak that later. Charges are of two types. For electric current to happen, charge should move with uniform speed, no acceleration. Otherwise, wave will be created. Since we study only current in grade 10, our charges will move only with uniform velocity. Then we understood the concept of conductor and insulators. All metals are conductor. If graphite as a non-metal is a conductor, then there should be presence of chapri electrons. And the chapri electrons are the delocalized electrons which form what is known as the pi bond. And pi bonds are formed due to sidewise overlap. Each carbon is linked with 3. Where did the fourth linkage happen? The fourth is a weak linkage. And not specific to electrons. The electrons overall like a mayonnaise layer spread on it, which is not seen in metals, other bases. In metals, this mayonnaise layer is not formed. In metals, all the electrons are happily moving. Right? आगे की discussion अगले class में.